Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Welcome to your first video lesson in Chapter 8. We are going to be covering 8.1 vectors and parametric equations, and then we are going to also be covering some more interesting topics as the videos progress. Miss Tan and myself, Mrs. Carmichael, are going to be taking you through some exciting definitions now. Miss Tan, take it away.
All right, so the first thing we're going to look at is the difference between what lines are and what vectors are. So if we go back to our definitions on vectors, vectors have a specific direction with a clear distinction between forwards and backwards. So by keeping this in mind, this means that they are unidirectional. Only one direction matters. But if we look at lines, they are bidirectional. So we can go in either direction, but we are still going along the same line, which means that there is no difference between forwards and backwards. For vectors, they have a finite magnitude, so we know the size of the vector versus a line continues infinitely along both directions. The next thing is that a vector has no fixed location. You can take a vector and you can move it into different spots in space, but you still represent the same vector that you have. But if you look at a line is very specific because it has to start somewhere and then continue. So then a different line with the same slope would start from a different spot.
So to make a line, similar to what we did back in grade 9, you needed 2 points. So from those 2 points, you could find the slope of the line. Or you needed 1 point on the line, and now we are calling what we traditionally have thought of as slope as the direction vector. So the direction vector is made up of 2 components, an A and a B. And that corresponds with the direction it's moving in X and the direction it's moving in Y, similar to what we have known before as our rise and our run. We cannot, for a direction vector, as you can see, A can't be equal to 0. And if it is, then we're probably talking about a special type of line, either a vertical or horizontal line is what comes out when one of those is equal to 0. All right, let's have a look at example 1 and see if we can understand the basics of this new idea of lines and vectors combined together. So we have state the direction vector, aka slope, for the line that passes through the So the line that passes through the points C, 3, 4 and D, 7, 2. So in order to find the direction vector between 2 points, we need to subtract the final point minus the initial point. Concepts from last semester. So I'm going to take the components in the x's and subtract them, and the components in the y. So 7 minus 3, comma, 2 minus 4. And this is going to give me a direction vector of 4, negative 2. It's also important to note that any scalar multiple could also be a suitable direction vector. So as we see here, other slopes that are direction vectors that would be the same would be 2, comma, negative 1 in its most reduced form. But any scalar multiple would do. All right, let's look at B. A line that has a slope of negative 5 over 3. Well, if I break this down, slope is rise over run. And I'm going to keep the negative with the numerator as just a rule of thumb. So I've got rise being my negative 5 and my run being 3. This means that my vector is always in the form, and I'm going to purposely write down here, run, comma, rise. So this is now going to be the vector 3, comma, negative 5. And again, any suitable multiple of this vector could be another direction vector. So if I took this and multiplied it by 2, I would get 6 comma negative 10. This is also another direction vector for the exact same slope. All right, let's look at C. A vertical line passing through the point negative 6 and 5. So to think about a vertical line, we're going to think about the slope of a vertical line. And if I remember what the slope is from grade 9 and onward, because we've been using it, the slope is undefined. And if I really start thinking about why it's undefined, it's because I'm dividing by a 0. So I have a number over top of 0. So when I did it in grade 9, I'd say, oh, I can't divide it, right? Because I've got 0 on the bottom. But in this case, I can switch it to a component form in vectors, and I could think of my component as 0, comma 1, I'm going to put in for now. It could be any number in this case. 0, 1 is the most reduced direction vector for a vertical line. So even though the slope doesn't exist, we still have a direction vector that would be associated with this. This point right now, at this stage in the game, is irrelevant, but we're just looking at the direction vectors for now. So what we're going to look at now is the fact that equations have two different forms. We're going to look at parametric form, where we have an equation for x component, equation for the y component, where it starts with x naught and y naught. That is the beginning point for x, and then it's going to partition us along a path plus an a comma t. In our vector equation, we have a starting point, x naught, y naught, and again we have a direction vector, ab, and t is something new we haven't necessarily talked about this year. T is what we call a parameter. So depending on what value of t, the parameter moves the parameter takes the point, adds the direction vector to it a multiple of times to create that line. So we're going to start looking at these types of equations. We're either going to have it in parametric form, which is the vector form, just split up into two different components. A special note about vertical and horizontal lines. The vertical line has always the direction vector form of 0, comma y. And the horizontal form always has the form of x comma 0. And we need to be able to look at these two direction vectors now and just realize that those are the vertical and horizontal lines now, similar to what we did in grade 9 when we had 0 slope or undefined slope. So we have to become comfortable to see where the zeros are and what line that makes it then be.
All right, so for example 2, the question is asking us to state a vector equation of the line passing through the points P 4, 1 and Q 7, negative 5. And when completing a vector equation, you have to keep in mind that we need two pieces to the equation. We need a point and we need a direction. So the first thing we want to figure out is the direction, all right, aka your slope, all right, which is equivalent to the direction vector that is PQ. So we can calculate that by doing the difference of the x's and the difference of the y's, which is negative 5 minus 1, which then gives us a direction vector that is 3, negative 6. So now that we have a direction vector, we need to pick a point. Doesn't matter which point we start with, no, so I'm going to pick the first point that we have, which is 4, 1, and then we're going to state our final equation, which is our equation. And it's going to be our line, is equal to our starting point plus however many multiples of our direction vector. Okay? And the one thing you want to keep in mind is that the direction vector can be any scalar multiple. And we do also need to define that t can be any real number because it is an entire line that's continuous across.
All right, we're going to look at example 3. Determine a vector equation for the line that is perpendicular to 4, 1 plus s, negative 3, 2. S is an element of the real numbers, and passes through the point 5 and 6. So we have seen these types of equations before in questions back in grade 9. Now we're vectorifying it. So here we go, Miss Tan. We're going to first look at the original slope that they've given us. They've given us a direction vector that's negative 3 and 2. So if I write that as a fractional slope, I'm going to be thinking it as the rise of 2 divided by the run of negative 3. If I want to think of a perpendicular slope, I've always thought of the negative reciprocal of it. So now I am going to flip it over and change the sign, which brings me to 3 over positive 2. This brings me now, I could think about my direction vector that's going to go along with this. This direction vector, this direction vector is now going to be 2, 3. And now my final step can be use the point they've given me, 6, 5. And I'm going to use this vector now that I know is perpendicular, 2 and 3. And I'm going to write the equation of a line. R is equal to 6, 5 plus t, 2, 3, where t is an element of the real numbers. And just like that, you have an equation of a perpendicular line.
All right, so we're going to take a look at our last example, which is a word problem. So we're going to take a road trip to Regina, people. The question is asking that suppose we travel on a highway from Regina to Stoughton, and it pretty much travels in a straight line, and we're going to express it in component form where east and north are the positive values. So our vector that describes our velocity is 85, negative 65. So they are asking how far south of Regina are you when you are at a position of 102 kilometers east of Regina. So the first thing you want to ask yourself is what exactly is the vector equation for this question? So the first thing that we know is that we have our velocity, which is 85, negative 65, and then I need to know where we're starting. So since they haven't given us an actual point to start with, we can assume that Regina is our origin, which is 0, 0. So to work out a vector equation, we end up with our starting point plus a parameter of our velocity vector, which is the vector that is taking us in the direction towards Stoughton, where t is any real number. But since we're only focusing on one component of this question, we can then break it up into the parametric equation that focuses on x components and y components. So x is equal to the starting point for the x, which is 0, plus the multiple that travels in the x direction. All right? And then for y, it is where we start plus the multiple in the y direction. All right? And if we want to clean this up, it can turn out to be 85t, and y is negative 65t. So the question is, do we need to worry about the y component? So in this case, since it's only looking at the east-west direction, the answer is no. So in order to figure out, we need to know how far south we are. But to figure that out, we need to know when we actually end up 102 kilometers east. So I can start with the piece that I know, because this is our x component. So I can then sub that into 85t and solve for t, which then works out to be, the magic of math is 1.2. So knowing this, the time piece has to be consistent with both x and y. So to find y, we sub that in, negative 65, 1.2, which then gives us a y value of negative 78. So they are 78 kilometers south of Regina.
Thanks for watching.
See you later.